Hey guys, this video goes along with section 6.5, which is about kites and trapezoids. Today we did an investigation where you had to measure several different kites and trapezoids and try to put together some properties that were special for all kites and for all trapezoids. These are the 5 properties that we came up with today as a class. So if you need to add any of those onto your sheet, here they are one more time, just to kind of refresh. Okay? We also talked about special properties of a trapezoid, and we said that all trapezoids have one pair of opposite sides that are parallel, and we know that these angles here are going to be supplementary. We also talked a little bit about a mid-segment, which we will continue to talk about in this video. And then we discovered that there's a special type of trapezoid called isosceles, that would be these yellow trapezoids here. And an isosceles trapezoid is when the legs are congruent, the diagonals are congruent, and the base angles are also congruent. Okay? Okay, so here are 2 examples that involve a mid-segment of a trapezoid. And we talked about today the mid-segment of the trapezoid can always be found by averaging the 2 bases together. So first you need to identify the sides that are parallel to each other are the bases, so 10 and 16. If I average those, it will give me the length of our mid-segment. So if I add 10 plus 16 divided by 2, finding the average, that will give me, I'm going to call it x. So 10 plus 16 is 26. Divide that by 2 and I would get 13 as my mid-segment. You could always check because it should be more than the small base but less than the large base, and it should be halfway in between them because it's the average. Okay, part B gives you one base and one mid-segment, and it's asking you to find the other base. Okay, so mark up your bases. This is your mid-segment, 17, and you are going to set up your equation the exact same way, but x is going to be located in a different position because you always find the mid-segment by adding the 2 bases and dividing by 2 because, again, you're finding the average. And in this example, that comes out to be 17. Okay, then we're just going to solve, multiply both sides by 2, and then get x alone by subtracting 15. So in this case, our missing base has a length of 19. Okay, properties of kites. Well, we just discovered today in class that opposite angles, one pair of opposite angles in a kite, all kites, are going to be congruent. Okay? Well, since 70 and 150 are not the same, that means angle J and angle L have to be the same. I'm going to call them both x. Okay? And we know something special about all quads. All 4 angles add to 360. So 70 plus 150 plus 2 missing angles, 2x, equal 360. So if you go ahead and pause the video, you should be able to simplify this equation and then solve for a value of x. Okay, if you want to just go ahead and check your answer for number 1, you should have found that x was equal to 70 degrees. So that means that this is 70 degrees, angle J, and also angle L is 70 degrees as well. Okay, now it's just a coincidence that this is also 70 degrees. It won't happen like that all the time. Okay? Example 2 says find the perimeter of this kite. Okay, well we know that diagonals in a kite are perpendicular, so automatically I've got a right triangle, which I can solve for the hypotenuse using the Pythagorean theorem. So a squared plus b squared equals c squared. That's what we're doing here. So I'm using 2 and 4 as my legs, solving for the missing hypotenuse. 2 squared is 4, 4 squared is 16, put them together, 20. I need to get x alone, so square root. Oops. And then you can simplify this since 4 and 5 are factors of 20 and 4 is a perfect square. Square root of 4 is equal to 2. So I've now found my missing side. Okay? So this is 2 root 5, this side here. I also know that in a kite, consecutive sides are congruent, so that means KE is also 2 root 5. Okay? Now we're going to use the exact same method to solve for the other sides of the kite. Okay, but now we're going to be focusing on a different right triangle, this right triangle. Okay, so now I've got a leg of 2, a leg of 6, and now I need this missing hypotenuse. So we're going to set it up the exact same way. 2 squared plus 6 squared equals c squared. 2 squared is 4, c squared is 36. Go ahead and simplify. And again, you want to simplify this radical into square root of 4, square root of 10. So 2 root 10 is your other hypotenuse, right here, as well as ET, since these are the same. Okay, now the question says find the perimeter. And we know when you're finding perimeter, you just add up all 4 sides. So I have perimeter equals 2 root 5 plus 2 root 5 plus 2 root 10 and another 2 root 10. These can be combined together since they're both root 5. So we have 4 square root of 5, and then same thing with the square root of 10, 4 root 10. And that would be acceptable if you just leave your answer like that. Okay, hopefully this helped you out. We're going to keep on practicing this tomorrow. So good luck to you.